Hi, I hope you guys are having a good day. Today we're going to go over section 6.2, inverse functions and relations. Two relations are inverses if and only if, wherever one has an ordered pair AB, the other has the ordered pair BA. So if B equals 1, 2, 2, 3, 3, 4, 5, 6, and C equals 2, 1, 3, 2, 4, 3, and 6, 5, then B and C are inverse relations. So if you notice, all that happened from B to C was that the ordered pair got flipped around. So instead of 1, 2, the inverse is 2, 1. Instead of 2, 3, the inverse has a coordinate 3, 2. Instead of 3, 4, the inverse coordinate is 4, 3. So that's how all of them are. 5, 6, the inverse is 6, 5. Okay, so find the coordinates of the inverse of the triangle having the vertices at 2, 1, 5, 1, and 2, negative 4. So all we need to do for that is write the inverse for each point, or the opposite for each point. So 1, 2 instead of 2, 1. The other vertex would be 1, 5 instead of 5, 1. And then the last one would be negative 4, 2 instead of 2, negative 4. If both the triangle and the inverse were graphed, the images would be reflected across the line y equals x. If two functions f and f to the negative 1 are inverses, and this f to the negative 1 power is the notation for an inverse. So when you see that, that means it's the inverse of something. Then f of a equals b if and only if f of negative 1 of b equals a. So for example, if you have two functions, f of x equals x plus 2, and the inverse of that function, x minus 2, I'm going to find f of 5. Okay, so f of 5, I'm going to substitute a 5 in for the x, and that equals 7. Okay, so now let's put the 7 into the inverse function. So the inverse 7 equals 7 minus 2, that equals 5. So that gives you back the original x that you put into the first function. And that's true of every function and its inverse. That's what's going to happen every time. You put a value in for x, you get an answer. Put that answer into the inverse, and you get the original x value back. Okay, to find the inverse of a function, write the function in equation form and switch places with x and y, and then solve for y. So on number 2, it says find the inverse. So instead of function notation with this f of x, I'm going to rewrite it using y. That's it. Puts it in equation form. So y equals, I'm also going to split this up into two fractions. X over 2, or 1/2 x, and 6 over 2, or 3. So I'm just rewriting it so it's not one number. Okay, so now I need to switch the place of the x and the y. So x equals 1/2 y plus 3. And I'm going to resolve for y. So I want to subtract the 3 and multiply by 2 on each side. So I'm going to have 2x minus 6 equals y. And that's your inverse, so you can put negative 1 for your final answer. Okay, so I also want to graph both of those functions. And remember that the graph in the inverse is going to reflect across the y equals x line. So it's going to reflect across this line that goes through. I'm just going to make it a dotted line. Okay. So let's graph the original line. And that's why I wrote it in slope-intercept form, because I wanted to have the intercept and the slope easy to find. So my intercept is at 3. The slope is 1 over 2, up 1 over 2, down 1 over 2. Okay, so your line's looking kind of like this. And then the inverse has an intercept of -6. And a slope of 2. So if we were to crease the line on the y equals x line, it should reflect across it. I think I drew my line a little bit off, and so I straightened it out some. You can see that it goes right where the two lines intersect. The y equals x line goes right through it. Okay, well, let's do the next one. G of x equals -1/2 x plus 1. So let's graph that first. Intercept of +1, and then the slope is 1/2. So it's a negative slope. Okay, graph that line. So the inverse, I'm going to switch the place of the x and the y. So x equals -1/2 y plus 1. Okay, and we solved for y, so I'm going to subtract the 1. X minus 1 equals -1/2 y multiplied by -2. -2x plus 2 equals the inverse, and I'm going to put my inverse notation there. So the intercept is at 2, right above it, and the slope is -2/1. So another negative slope, and it's going to go through like this. Oops, I'm not making this deep enough. Okay, there's your other graph. This is your f of x. This is your inverse. Okay, so two functions are inverses. Now we're at the bottom. We're going to finish this up here. Two functions are inverses if f of g of x equals x and g of f of x equals x. So what that means is I'm going to find f of g of x, and after I substitute the g function into f, it should equal x after you simplify it. And then I need to do it the other way around. I'm going to substitute f into g, and I should get x again after I simplify it. So let's do this first part. I'm going to put g into f. So here's my f function. In place of the x, I'm going to put 1/5 x minus 2, and then simplify. So 5 times 1/5 x is x minus 10 plus 10, so that equals x. Okay, so that one works. Now I need to test g of f of x. So now I'm going to put my f function into the g. So 1/5 times 5x plus 10 minus 2. 1/5 times 5x is x. 1/5 times 10 is 2, minus 2. And that one equals x. So yes, they are inverses of each other. Okay, so on your assignment, they're going to give you two graphs, and they're going to want you to decide if the inverse of that graph is going to be a function if you use the horizontal line test, what they call the horizontal line test. So this is an example of the horizontal line test. Let's say you have a graph. I'm just going to make it simple. And the vertical line test is if you take a line, a pencil or your finger or something, and move it vertically across your graph, it's only going to be a function if it hits just one spot on that graph at a time. So in other words, your x value cannot be repeated. Well, since your inverse graph is reflected across the y equals x axis, we're going to use the horizontal line test to see if the inverse would be a function. And so you cannot cross the graph in more than one place at a time for the inverse to be a function. As you can see, this it's not working on this one. So this inverse would not be a function. So you'd say f of x is a function. The inverse of x is not a function. Okay, so kind of a short lesson today. Make sure and write down any questions that you have so we can go over it on Monday. And I hope you guys have a really great weekend. Try to stay warm. Bye.